Hey everybody, today's lesson we're going to talk about lesson number 17, nuclear reactions. Now the big idea here is nuclear reactions have provided us with energy that's clean, but oftentimes seen as dangerous. Now how does that happen? Well, there's two types of nuclear reactions we're going to talk about. We're going to talk about nuclear fission and nuclear fusion and how they are different. So let's get started. What is nuclear fission? Well, what nuclear fission is, well, fission comes from a word to split. So what that means is you are actually splitting a more massive nuclei into smaller, less massive nuclei. And because of this action, this produces energy. It releases energy, which is good for if you want to produce energy. But you still get nuclear waste. It also produces nuclear waste. So it produces things that we don't want. So what happens? What happens during a fission reaction? Well, you have a neutron. So here's a little tiny neutron, okay? This neutron is going to collide with a radioactive chemical, a massive nuclei. And what's going to happen is when this happens, it's going to break itself apart into a smaller nuclei, into another smaller nuclei, but it also expels more neutrons. So what ends up happening is this is the massive one, and these are the smaller ones. But what's going to happen to these neutrons? Well, these neutrons will thus, again, collide with another massive nucleus that's radioactive, and it too will produce smaller nuclei and more neutrons. And these ones, again, will then continue on that trend. And we call this process a chain reaction because once it starts, it won't actually stop. And if you don't control this, it could lead to violent nuclear explosions. So why and how can we control it? Well, in nuclear power plants, we actually control it really well by making sure that this chain reaction is undergoing a much more cooler and controlled reaction, and we use a lot of cooling processes such as heavy water is one of them. But how is that different from fusion? Well, fusion means to join. It means to join. So guess what? It's the opposite of nuclear fission. Not only is it the opposite, this time it's two smaller nuclei join to form a more massive nuclei. And this process too also produces energy. But do we get this on Earth? Is this possible on Earth? Well, if you flip to the next page of notes, we can actually write down a few more things. This is actually very difficult to produce on Earth. Very difficult to produce. And the reason why is because it needs very high temperatures and pressure. Now, where can we get these high temperatures and pressure in our universe, for example? We get them on stars. This is why we get this in stars. Stars are giant nuclear fusion power plants. That's why stars produce so much energy. Our sun is a star, and that's why we can feel its warmth that it produces from that nuclear fusion process. So if we were to look at this as a table, what you're going to see is the difference between fission and fusion, where we're going to see that fission is a splitting of a large atom into two or more smaller ones, while fusion is the opposite. It's joining two smaller ones into a larger one. Fission reaction does not occur normally in nature. That means we actually create this, but fusion does occur in nature in stars. The byproduct of fission is that it produces nuclear waste, while for fusion it's fairly clean. There's few radioactive particles are produced. And in terms of condition, critical mass of the substance and high speed energies are required. That means in order for this to happen, you need some high speed neutrons to be formed. While in fusion, you need high temperature and pressure for this to occur. So that's a big difference between nuclear fission and fusion. And if you want to find out more, there's many great videos online showing you how nuclear power plants work, and also showing you a live version of how fusion and fission work. As always, make sure you stay safe and healthy, and I'll see you soon.